Good morning, how are you? Today we are going to make a little review about potentiation, okay? So we have here the first example, 2 elevated to the third potentiation. So this is the same as 2 times 2 times 2. So the number 2 appears 3 times, and this gives me 8 as a result. So here we have 4 we call base, 3 we call exponent. 4 times 4 times 4 is the quantity that the number 4 appears, so 3 times, right? Those are the terms we use for potentiation. Let's go. Now, again, a little review about the terms, math terms. So the exponents. I have 5, my base, 3 is my exponent, and the result, the final result of it is my power. So we have an example here. 125 is the same as 5 elevated to the third exponent. Means that 5 to the cubic is the exponential form of the number 125. Okay? Now, let's see some examples with the exponent 1. 5 elevated to 1 is 5. 4 elevated to 1 is 4. 0 elevated to 1 is 0. 2 elevated to 1 is also 2. 3 elevated to 1 is 3. So A elevated to 1 is A. And A is any number positive, okay? Any natural positive number, okay? That's what we are studying now. The natural numbers, the numbers that we use to count. Then 2 elevated to 0 is 1. 3 elevated to 0 is 1, 4 elevated to 0 is 1, 5 elevated to 0, 1, 6 elevated to 0, 1. So A elevated to 0 is 1 for any number natural that is higher than 0, okay? Then 0 elevated to 1 is 0, 0 elevated to 2 is 0 times 0, which is 0 as well. 0 elevated to the cubic is 0, so 0 elevated to any exponent is 0, okay? Now, 10 elevated to 1 is 10. 10 elevated to the second power is 10 times 10, that's 100. 10 elevated to the third power is 10 times 10 times 10, which gives me 1000. 10 elevated to the fifth power is 10 times 10 times 10 times 10 times 10, which is 10,000. Take a look that the number that it's my exponent is the quantity of zeros I have in the result. See here, we have 2 zeros, 3 zeros, 5 exponents, and we have 5 zeros at the result, okay? Now, let's take a look on this. 2 elevated to the fifth power is 32. 2 elevated to the fourth power is 16. If I want to go back, I want to walk back, I need to divide by 2. If I want to move forward, I have to multiply by 2. I'm here with the potentials of the number 2. 2 elevated to 1 is 2. 2 elevated to the second power is 4. 2 elevated to the cubic is 8. 2 to the fourth is 16, and so on. So take a look. When I want to move on, when I want to move forward, I multiply by 2 to get the next power, okay? And if I want to go back, I need to divide by 2. Do you see? The same stuff happens here. 3 elevated to 0 is 1. 3 elevated to 1 is 3. 3 elevated to 2 is 9. And like this, it goes. So, if I want to pass from 3 elevated to 0 to the next power, I multiply by 3 because my base is 3. And like this, the same way, if I want to move on again, I multiply by 3, so if I go forward, I multiply by the number that I have in my bases. If I want to go back, I divide by the number I have in my bases, okay? So coming back, I divide, going to the front, we multiply. Now we are going to have a look in some potentiation properties. 2 elevated to the second power and then times 2 elevated to the third is the same as we repeat the base and we add the exponents, okay? 2 plus 3, it's 5. Here I'm not worried about solving this quantity. I just want to see the property, okay, of the exponent. If I have a multiplication with the same basis, I repeat the base and I add the power. Here, 3 elevate to the second power times the 3 elevate to the first power. So I repeat the base 3 and I add 2 plus 1, which gives me 3. 4 elevate to the second times 4 elevate to the fifth. I repeat the base 4 and I add 2 plus 5, which gives me 7. So for any number, natural number, positive, and elevate to the n exponent times the same number a, elevate to the m as exponent, I repeat the base a and I add n plus n. And remember that a and m are natural numbers, okay, numbers that we use for counting. Now we are going to see another property for division. 3 elevate to the ninth form divide for 3 elevate to the sixth form. I repeat the base 3 and I do subtraction here, 9 minus 6. So I have 3. The same happens here. 2 elevate to the fourth exponent divided to 2 elevate to the first exponent. So I do repeat base 2 and I do subtraction, 4 minus 1, and I have 2 elevate to the third exponent. 4 elevate to the fifth divide for 4 elevate to the 0. I repeat the base 4 and I subtract the exponents. 5 minus 0, it's 5. So for any number a, natural number a, elevate to the m as exponent divide by a elevated to the nth exponent, I repeat the base a and I do the subtraction, okay? Remember that they are all natural numbers. This is just a generalization of the examples we are seeing, okay? Then another property. When I have a power between parentheses elevated to another power, I multiply those powers. Do you see? 2 times 3, it's 6. Here, between parentheses, 1 times 2 is 2. Here, 2 times 6 is 12. And here, a elevate to the n times m. Remember again, those numbers are natural numbers. In this kind of property, I can generalize with more bases inside of the parentheses. It will happen the same stuff. Look, 2 times 3 times 4, everything elevate to the third power. So it's base elevate to the third power. So 2 elevate to the third times 3 elevate to the third times 4 elevate to the third. The same as here. I have everything elevate to the second power. 2 elevate to the second times 5 elevate to the second times 7 elevate to the second. Again here. 4 elevate to the fourth times 5 elevate to the fourth times 6 elevate to the fourth. In a generalization, a times b times c elevated to the nth exponent. I have a elevated to the nth times b elevated to the nth times c elevated to the nth exponent, okay? Now let's see some numerical examples. 8 elevated to the fifth times 8 elevated to the 7. I repeat the base 8 and I add 5 plus 7 is 12. 5 times 5 elevated to the 4th, 5 times elevated to the 7th. Take a look here. The 5 has no exponent. This means that this exponent is 1. So I put 1 plus 4 plus 7. This is 12. Okay? Now, 10 elevated to the 9th, divide for 10 elevated to the 6th. I repeat the base 10 and I do subtraction. 9 minus 6, which is 3. Other examples, now with parentheses. I have base 2 and I have a power inside the parentheses elevate to another exponent. So I do 3 times 5, which is 15. Here the same stuff. I repeat the base a and I do 4 times 3, which is 12. Here the same. I repeat the base 3 and I do 6 times 0, which is 0. Here I repeat the base 5 and I do 1 times 8, which is 8. Here generalization again. 2 times 5 times 7 elevated to the second. This is 2 elevated to the second times 5 elevated to the second times 7 elevated to the second. Here 2 elevated to the fourth times 3 elevate to nothing, so it's 3 elevate to 1, times 5 elevate to the second, elevate to the third. So it's 2 elevate to the 4 times 3 elevate to the third, times 5 elevate to the 2 times 3. So here it's going to be 12, okay? 2 elevate to the 12, 3 elevate to the third, and 5 elevate to the sixth. Here 5 times 11 to the second power, everything elevate to the second again. So 5 elevate to the second times 11 elevate to the 2 times 2, which is 4. Okay? Now let's see the power of 10. 10 elevate to the 6, 10 times 10, 10 times 10 times 10 times 10. So I have 1 followed of 6 zeros. Do you see? I have the exponent 6 and I have 6 zeros in the answer. 100 elevate to 1 is 100. Okay, because any number elevate to 1 is the number itself. 1 elevate to the third power exponent is 1, because 1 elevate to any number is 1. 2001 elevate to 0 is 1, because any number elevate to 0 is 1. Right? So now we finish our presentation. If you have any doubts, you tell me and we are going to see next class. Okay? Thanks for watching the video. See you.